Hi, this is Amri, and I'm going to present to you today, in partnership with Microsoft Azure, OmniClouds platform to transfer. We are the secure route to Azure. Today, in Advanced Networking Workshop session, on the 11th of August 2020, what we're going to present to you today is the unique capabilities of an SDX platform that is natively operating layer 2, layer 3, up to layer 7, full automated and self-healing network that is connected to every data center of Microsoft, allowing Microsoft and Azure customers and partners to be able to seamlessly and securely deliver an excellent Azure experience. OmniClouds network is designed with the customer at the center of it. The customer's experience of using the cloud, the better experience for the customers, the more consumption, and at the same time, a true business value is delivered by transforming from a traditional business model to an Azure WAN business model. As you can see from the map, OmniCloud covers EMEA and North America region and parts of Asia. A company with headquarters in Singapore, United Arab Emirates, Kuwait, Bahrain, Egypt, East Africa, Europe, and the US, serving customers all around the globe and serving partners all around the globe. Our dedicated network, combined with the state-of-the-art software-defined orchestration platform, spread with gateways across all the countries we operate in, has a dedicated 10 gig backbone links connected to all its gateways together, along with its orchestrators, and at the same time, the same network is connected to all the data centers where customers can move workloads or use workloads seamlessly. On the OmniCloud platform, combined with Azure WAN, customers could enjoy up to 10 gig from their headquarters, branches, data centers, head offices on a dedicated basis or on a best effort basis. And why I would say that? Because for the customers in Middle East and Africa, there are few challenges that pushed us to innovate a solution that could help the customer from his branch and his office anywhere in Middle East and Africa, and actually Europe and even the US, that they can combine multiple links together, be it 3G, 4G, 5G, ADSL, MPLS connectivities, or DIA separately or combined together. This is used for a short period of time if they want to transfer large data to Azure, or for a continuous periods of time, and that could all managed on a monthly subscription basis, and that could scale the bandwidth literally for 1 meg all the way to 10 gig. The services reaching Azure is a fully managed services or best effort services. On the fully managed services, it comes with an SLA where customers can set their business priorities, and from that business priorities, they would actually be able to set exactly the priorities for branches or data centers or their head offices, or which workloads or applications have priority to utilize the bandwidth that is being used, whether locally within inside the country or internationally within the Azure cloud, or even between the branches itself. As I said, it's a fully managed and automated through OmniCloud SDX. Branch provisioning, headquarters provisioning is a zero-touch provisioning through our portal, which you will see with my colleagues later on the live demo. A full orchestration and analytics layer that is accessible through a website or your partner portal. If in case of partners, we allow our partners to have access to their customers' portal if they want to manage it on their behalf, and even if they want to manage their workloads, and that becomes itself a service. And at the same time, our provisioning is based on profiles and templates, which we build for our customers or our partners' customers. I'd like to talk a little bit more about Azure Enhanced User Experience. What is it that we're talking about? We're talking about security, latency, throughput, and reliability. With enterprise shifting their core infrastructure and services to the cloud, security has become #1 priority for cloud connectivity. Hence, our services come with all Azure security offering, along with OmniCloud security offering built in the device, in the CPE itself, and in our cloud, where the customer can pick and choose which security services they can use. Moreover, we have a 24/7 NOC and SOC that serves our partners and our partners' customers. Latency. Since we built our network as OmniClouds globally using layer 2 and layer 3 connectivity, we meticulously built it and chose submarine networks, terrestrial networks, with exactly calculated latencies where our layer 7 platform would be able to divert or reroute your applications based on the application quality of service or profile requested by the customer. And all that is done through a user-friendly interface, which allows customers to use it for live streaming, telemedicine, banking, stock brokerage, and more of applications. The high throughput is another key requirement that helps customers get the best out of their cloud platform. Many situations, partners or customers would not be able to fulfill the requirements of their customers or their business partners because the experience of reaching the cloud, and I repeat here, it's reaching the cloud, not the cloud itself, misplaces the performance issue from being difficult or challenging to reach the cloud to perform your workloads to, do I really need the cloud? And that hinders the efforts to a full successful transformational journey that would yield at the end of it a successful business practice. And that is what we come in to help. We come in to make sure we optimize and rationalize the total cost of ownership of the customers to reach the cloud, make sure the customers would divert their true OpEx investment to Azure, true OpEx investment to application modernization, instead of spending it in expensive telecom charges that they might not need. And at the same time, we make sure the applications are optimized in a way that serves the customer demands, whether it's end of the month and salaries closing, or beginning of the month and sales and CRM is being accessed. Reliability of private connectivity services make it an obvious choice for most customers looking to get the best out of their cloud platform. Today, with the point of sale being on the cloud, retail applications being on the cloud, and much more applications, video on demand services being on the cloud, customers are requiring to use a private connectivity. We believed in OmniCloud exactly as Microsoft believed that the cloud is the network. And when you have all your workloads and all your branches connected to the cloud and to Azure, Azure will manage your network. And for you to reach that, you will have to use services like OmniCloud SDX services that would make you seamlessly and securely, with reliability, reach the cloud. When we talk about Microsoft Advanced Networking, we remember the days of the World Wide Web, where the internet is a 1960s service that was developed originally to have a point-to-point connectivity, and then multi-point connectivity, and then browsing of the web. Today, we transfer our MRI and our CT scans. We do our teleconferencing calls. We use Teams all the time. We watch our videos and our video on demand. We connect to our point of sale systems. We check our inventories and our stock provisioning, all on the cloud. Branches are becoming ghost branches for banks. Retail chains are becoming ghost retail chains where people can check out. We primarily depend on the cloud, and we depend on Azure to reach our cloud. In 99% of the situations, the cloud performance is a superb cloud performance. The issues are always the last mile, and the issue is always reaching the cloud itself. That's why from VNet to virtual WAN to express route to VPN to DNS, if we look at the express route services and the virtual WAN services, and you add them both together, you will come at the Microsoft Advanced Networking. Few years ago, we used to have VPNs to reach our cloud workloads. And then we started using the express routes, where we have some sort of dedication, which comes at a price. And later, we can combine both express route, virtual WAN, along with an innovative SDX platform that could combine lots of connectivity together and give the customer a true, seamless, advanced networking experience. It connects, it protects, it delivers, and it monitors the services. And that will all come during the live session. As you can see here, the Microsoft Virtual WAN setup is as we see it. On a traditional WAN, you have the VNets and you have Azure, and then connected to them, you will be using an express route. Express route comes at a standard prices from Microsoft Azure. However, from the local operators across the world, prices differ. It differs depending on the availability of last mile at the customer branches or customer's headquarters, which means you will have to use at the customer premises, whether branches, headquarters, or factories, a VPN, which will take you to a cloud that will connect to an express route, and then you connect to the WAN. The more junctions we add, the more effort and issues and non-seamless performance, let alone the remote users. You connect to Azure Virtual WAN today using OmniClouds, and as you can see on the right side, you connect to OmniClouds CPEs. OmniClouds CPEs will use LTEs, will use ADSL, or any other connectivity. For the remote user, they will use the SASE service, which also is provided, and customers immediately will reach the OmniCloud orchestration layer, and from that layer, which is seamlessly connected to Microsoft Azure, everywhere in the world, you are connected to all your workloads. And from your workloads, as you can see, the cloud starts becoming your network. To go briefly about how you can use Azure WAN connectivity with OmniCloud products, which is OmniBranch to connect branches and headquarters, OmniConnect to connect branches to clouds, and OmniRemote to connect SOHOs and remote users, like the situation in COVID where people were working from home. What you achieve is a private cloud for each department using either WAN, LTE, ADSL, MPLS, and also we manage the customer's Wi-Fi. And a unique feature of OmniCloud's network, other than connecting the LTEs, ADSLs, and MPLS, is also having a service of managing your LAN components behind the CPEs at no extra charge. Managed security, zero-touch provisioning, Azure WAN Express. All branches enjoy access to express connectivity to Microsoft Cloud services. Branch to branch, no more VPNs, all is mesh connected, and at the same time, from a customer assessment all the way to services running, it takes 2 to 4 weeks maximum, including the provisioning of the cloud services on Azure. Our formula for Microsoft partners for their growth is that we offer the whole OmniCloud SDN, SDX dedicated backbones connected to Azure data centers, services that scattering for remote user branches, local data centers, and international data centers. It enhances Azure customer experience, accelerates your sales cycle and closure rate, and OmniCloud services could be resold as part of OmniCloud, or it could be branded for large organizations or for government entities. Again, I would like to thank you very much and encourage you to see the live demo and save your questions for the last 20 minutes of the session. Again, thank you very much and welcome to Azure WAN.
Hi everyone, welcome to OmniClouds. My name is Mohammad Khubaib and today we will be discussing about the virtual WAN circuits, how to create a virtual hub with a VPN gateway, integration of OmniClouds SDX platform with Microsoft Azure, creating communication between on-prem SDX device to Microsoft Virtual Hub VPN gateway. So first of all, we need to go to the virtual WAN service and create a virtual WAN circuit. It is very easy to create a virtual WAN circuit. First of all, we need to go to the resource group and select it. In the resource group location, we can select the appropriate location. We will give the name and just click next, review and create. So it will run the final validation. And once it is done, you can click on create to create the virtual WAN circuit. As I have already created a virtual WAN circuit, so let's go inside and see the overview. As we can see, it is in the resource group virtual WAN. The status is showing as succeeded. The location is showing as UK South. The branch to branch is enabled. We have two virtual hubs inside this virtual WAN. So for each virtual WAN circuit, we need one or more hub. These hub sites contain VPN gateways, point-to-site gateways, and express route VPN gateways. So let's see how to deploy a virtual WAN virtual hub. First of all, we need to select the region in which we need to deploy the virtual hub. We will give the name. This from in here we have to put an address scheme. Click on next. As for this demo, we will be needing a site-to-site VPN gateway. So we will click on yes. Gateway scale unit we can select for now as 500 Mbps. So this VPN site-to-site gateway will be creating two tunnels of a capacity of 500 Mbps per tunnel. Click on next. Point to site. This is used for the user VPN gateway. If the remote user want to connect to the workloads in Azure, we can also create point to site gateways. We can also create our express route gateway for a direct connectivity to Microsoft Azure. We can tag our resources as per the choice. We will click next, review and create. It is running the final validation, and as we can see, the validation has passed. We can click on create to create a hub with a gateway, but it is showing that creating a hub with a gateway will take up to 30 minutes. So we have already created a couple of hubs. So let's go into a hub UK South and see what's inside. In the overview section, we can see the name, the private address space, the hub status, the location of that hub, the routing status, and also virtual network connections. So I have connected two VNets to this hub. And as we can also can see that VPN site-to-site gateway is also provisioned successfully. Now we'll move to OmniClouds SDX platform and see how the OmniClouds SDX platform is integrated with Microsoft Azure. We will go under the Administration tab, go under Connectors, click on CMS. As we can see, we have two connectors. So let's go inside and see how it is configured. So in these fields, first field, the CMS name we have to give, that can be anything. CMS flavor is Azure. You can also select the environment, public, China, or Germany. We have to put the subscription ID. This client ID, tenant ID, and the key can be obtained from the Microsoft Active Directory by creating a service application. Once we put all the details, we click on OK and it will save. Then we can validate this connector and credentials through this button. As you can see, it is checking that the credentials are valid. Now we will add this connector to our appropriate organization. Let's go and do that. We'll go to the OmniClouds, the organization name, go into the CMS connectors. As you can see that there are no CMS connectors now. So with a single click, you can add or remove. So I have added again. Just click on OK and see the role successfully added to the organization. You can also see the CMS connectors over here. Now we will move to the most important part, the template. So in OmniCloud SDX platform, first we need to create a template for the device in which we define the interface information and the next generation firewalls, tunnels, split tunnels, direct internet access, and the subscription models. Then attach that template to the devices. So in this basic tab, we have to put the name of the template, the organization. We need to select the device type, whether it is a bare metal device or it is a virtual CPE in the cloud. Then we have to select whether the device will be working in full mesh, hub controller, or a spoke. We can also have a redundant pair of device which will work as a VLRP in active-active or active-passive mode. So we need to add the controllers over here, which manages all the control planes and the connectivity all over the organization. In the subscription model, we have multiple subscriptions which varies as per the offers, and all are rich in features. In the service bandwidth, we support up to 10 Gbps in terms of total bandwidth of multiple LTEs, ADSLs, MPLS, DIAs, lease lines, etc., which are all bonded together with site-to-site connectivity. In the next tab, we will define the interfaces, and in the OmniCloud SDX devices, the interfaces are not hardly coded. So we can have multiple WANs, multiple LANs, multiple LTE connections, multiple Wi-Fi connections, and for the higher end models, we support up to 16 ports. And in that, you can have N-1 WAN connections. So it is very simple to add a WAN port or a LAN port. So in this WAN interface section, we can select the network name over here. We can select whether the assignment is IPv4, scheme is IPv4 or IPv6, whether the IP scheme is static or DHCP. We also support IPv6 with the static and DHCP options. And also with a single click, you can enable the management on the WAN interface. We also support sub interfaces under a single port. For now, let's just remove these things. In the LAN one, you can add LAN port, select the organization, select the routing instance, and you can assign IPv4 static or DHCP, or IPv6 static or DHCP. You can also add sub interfaces under the LAN as well. So for now, let's leave this part and move to the routing, the next step. We also support BGP, IBGP, OSPF, OSPF v3, and also static routes. All of the configuration is very simple and it's just a matter of clicks, and you can enable the most advanced routing. In the next tab, we have two sections. One is split tunnels and one is side-to-side tunnels. In the split tunnel, this is the same concept as a local breakout. So this LAN, so for configuring that, we need to just select this LAN VRF, select the WAN interface, click the radio button of DIA, direct internet access, and the gateway. If we enable this check, this device will be serving as a gateway for all the devices in the same organization. With a single click, you can add, and if you want to load balance all these links for the internet traffic, then click here, and all the links will be load balanced. Now, this is the most important part for Azure Virtual WAN. We need to give the name, demo site. We need to select the plugin. The peer type is a plugin in which is built into the XDX platform and which knows how to create a connectivity automatically to the Microsoft Azure. You can select the WAN or LAN network. We have to select the LAN VRF to propagate the routes with the help of BGP. Just check this and add. It will automatically add over here, just a single button. For now, as you can see, we have already configured one. So let's move to the next part, the inbound NAT. If you have a resource behind NAT, you can also put a static IP and NAT it. In the services tab, you can run the DHCP servers on the LAN interfaces. You can just click DHCP option profile and just add the specific details, and the DHCP server will be running. We also support DHCP relay. The service template, we have a security option in which we are providing next generation firewalls and stateful firewalls. You can also configure under the management servers, you can also configure the NTP servers, syslog servers, FX servers, Radius servers, SNMP managers, and also integrate it with the Active Directory. So here is the part where you will create the Wi-Fi connections. So once this is done, you just have to click on Recreate and move to the next section of. So now we will associate that template to the device. In the devices section, under the workflows, we'll go to the appropriate device, Azure Virtual WAN. We'll give the name of the device. We'll give the OmniClouds organization. You can select the deployment type as CPE bare metal or CPE public cloud in case of a virtual CPE in the cloud. So in this device group section, we are associating the template which we have created before. So we have to give the name. The post staging template, we can select that template over here. Give the contact information of the administrator, and here we can use URL-based ZTP and staging. Once this is done, you can click on OK to add. But we have already done that. The device group is already added. We can also put the admin contact information. In the location information, we can put the address and click on get coordinates. This will get the coordinates from the APIs. Then the next tab, the tunnel information. This is the main tab for Azure Virtual WAN. So here we will select the site which we have created, OCV WAN. The peer type, which is the plugin type, we will select Azure Virtual WAN. So here we will select which connector do we want to use. We want to use Azure Connect OmniClouds 2. In the region, we need to select the Virtual WAN circuit region, UK South. Now it is fetching all the information through the APIs from the Azure port. Virtual WAN ID, resource group, the LAN address space, which will be propagated through BGP onto the VPN, through the VPN gateway to the other VNet. So we will give the LAN address space. The pre-shared key can be anything. And the private BGP AS number. We can give any AS number from the private range except for 65515, which is Microsoft proprietary. And just click the add button again. We will add the VPN tunnel onto the Azure once it is redeployed. As we have already created, we will move to the next step of URL-based ZTP. This is the section which is used for deployments or initial activations. If you have a static IP address while activating, you can put over here. If you have a DHCP IP address, you can just click on this button. If you have a DHCP v6, you can also put over here. If you are a home user and you want to run it over a VPOE connection, then you can select and give the username, password, service name, and access consent data. We'll move to the next stage of buying data. This is the most important part where we put our internet static IP addresses, the LAN IP addresses, the LTE static IP address of the dongle, the Wi-Fi IP address of the interface, and also the next hop for the private IP addresses. In the auto-generated tab, you can see that the OmniCloud SGX platform is managing each and everything for the IP sectors and also the router IDs for the internal BGPs. Once this is done, we have to click on redeploy and we will see the tunnels creating over here under the VPN site to site. Azure Virtual WAN, OCV WAN, we can see the connectivity status is connected. The public IP address is here. The speed is showing 4 Mbps. Provider name is OmniClouds. And the BGP address is this. So on the OmniClouds SDX platform, you can go to the Monitor tab and search for our device. We will go to the summary and we can see the tunnel virtual interfaces The two terminal virtual interfaces of 500 Mbps of bandwidth can be seen over here, and they are operational up, and also the admin is up. To check the routes, we can see into the OmniClouds LAN VR, the all routes which are coming to our terminal virtual interfaces. This is my VNet on Azure, and this is the hub private IP address space. Now, we will ping from the device to one of our virtual machines. So let's go to the Azure portal, go to the virtual machines, click over here. You can see the details of the machine, the size, public IP address, status is running, location is UK South. You can see the private IP address space. Private IP address is 10.10.9.4. So let's try to ping it from here. We will select the LAN via the source address. We will put 192.168.139.1, which is the LAN interface IP address of the device. Click on start. As we can see that there is no packet loss, 10 packets transmitted, 10 packets received. Thank you for joining this technical demo.